Hello everyone and welcome to this online lesson. Today we are going to be looking at x-rays and blood transfusions in the trenches course. All right, so quite interesting actually. Well, this whole trenches course is interesting, but focusing particularly on the progress that began to be made on x-rays and the blood transfusions is epic, a really important part of World War One and the moving forward with new technology and new ideas. All right, so with that said, let's get straight into the lesson. And we'll begin with a reminder of what we've talked about earlier in these trenches course, some of the sources that you might be able to use to find out more. Remember that third question in the trenches paper is how do you find out more? What questions can you ask? A little reminder of what we've already talked about, the types of sources you might use to help you answer the question that you go on to make up. So we have national and local newspapers, articles and journals, and they'll be useful for things like discussing new training, or the purpose of why those sources might be in your exam paper would be definitely for training or informing doctors in how to do something, which of course would make it even more useful because it's got to be right in order for the new procedures to be carried out. Also, obviously, photographs, they're always a brilliant source. Remember, with a photograph, it captures a moment in time. It's probably, remember that T word, typical, a typical scene, and you'll expect it to be. If you would see the photograph and you think, well, wherever this was taken on the Western Front, I would expect something similar, then that makes the source useful. All right. National Army records, statistics, individuals and battles, of course. We talked about those official formal records that tell us things. And obviously we need to consider, probably more importantly, the purpose of why some of these sources might be done. Government reports, they may be to make people the government think the war's going well, or maybe to make them see the war's going badly. So they need support in some way. But the most important one that you need to think about, the vast majority of cases when you are using a source in that third question, is you'll say RAMC medical records from a base hospital or a CCS on the Western Front. That's generally speaking your go-to source, because from that we can work out almost anything related to types of injuries or treatments, things like that. But of course, if we're looking at a question that's focusing on transport of the wounded, then you may not be able to necessarily use those records, but there will be records from diaries of the nurses driving them, or personal accounts from the soldiers themselves. So altogether, we've got just a handful here of sources that you could use, but your go-to generally, remember, is RAMC medical records from the CCS or the base hospital on the Western Front. You need to include all of that, not just RAMC medical records, because the question is asking you about the Western Front. All right, so little recap there. Hopefully that's getting more secure in your mind now as we go through this course. So a little subtitle in your notes, perhaps, in this next bit is just how did the development of x-rays, aseptic surgery and blood transfusions develop in World War One? In this case, when we say develop, we definitely mean got better. All right, so we'll start with the x-ray, this machine that you can see in front of you. So just pause the video and write down a few ideas of what you can see. What might the problems with that be? Just what can you see? So picking out some content before we have a focus or anything else, just what can you see from this x-ray? Okay, we'll use this later on in the lesson. When you're ready, unpause the video and we'll carry on. Okay, so some context first before we look at the three specific bits, the x-rays, the blood transfusions, and think about some aseptic surgery. Remembering where we've come from on the medicine course, just pause the video now and complete this flowchart with a little bit of a recap for yourself, some revision on the germ theory. How has the germ theory then led to Lister and its antiseptic in surgery? Then how has that led to Koch's discoveries of the microbes? And then ultimately the last box already done for you, but just make some notes on that. You need to try and tell this story about how we've got from the germ theory. I know this is the trenches course, but it's an opportunity to link the two and just practice your revision really for that really key topic and key discovery of the germ theory. Once you've done that, unpause this video and we will carry on and we'll start with the x-rays. All right, so you have got some notes in your work already, some ideas about what you can see. So let's now describe the main features of the x-ray machine. Obviously, one of the features that hopefully you've written down is the thing is massive. You can see that it's used by some sort of hand crank. The doctor or the person using it, he's got a white uniform on. That might be important. We could find out later. And we can see that this is generally indoors. So there's some features there that jump out at us straight away without any knowledge. And now we'll add a little bit of extra detail to that, and probably things that you're more likely going to include in an answer. Particularly if it's question 1, that would be absolutely brilliant. Give one feature of the early X-ray machines in the hospital. So we've got a bit of a description there already. Number 2, what problems might arise from this? We'll talk about that in one sec, so you can answer that in a second. What other types of sources might help you understand the problems linked to the use of X-rays? So when we get through the detail in a sec of the early problems, we're going to be thinking about what questions could we ask to find out more, and therefore which source. What source will help us get more information about the X-ray than perhaps another source. So you're going to write down now in your notes that they are large and very difficult to move around. We can see that from the photograph. This is obviously not going to get anywhere near the trenches. The terrain just would not allow it. We can see it's got these sort of feet, I guess you could look at them, wooden feet. There's no way we're getting this in and out of the trenches particularly easily, so we know that it's going to be limited in its use. All right, the glass tube is very, very fragile and could break easily. That's an important feature to think about. And at first, taking an X-ray takes about 90 minutes. This is not ideal if you have a bit of shrapnel or a bullet in your arm or your leg or wherever they're trying to find this thing. 90 minutes to try and be still in order to not make the picture come out bad. These are the early problems, all right? So it's a brand new thing, but fantastic in its principle of what it can do. Large amounts of radiation, so about 1,500 times the amount released today. Which means that the patients often were burnt and their hair fell out. Okay, so we got 4 interesting features, or 4 features that you might stick to. The obvious feature is going to be the purpose of the X-ray, in order to see where bones are broken, shrapnel or bullets are in the body, and so they're trying to feel around in there, squelching about. They can take an X-ray and they can see exactly where it is, and they can see exactly what the damage is. This is why this is really quite useful, and progress, and obviously got better as the war went on. Okay, so we've now definitely included in your notes the features of the X-ray, or the first X-ray. Later on in this course, in another lesson towards the end, we'll have a look at the invention of the mobile X-rays, which can get closer to the front line, probably still not in the front line, but closer, and they're smaller. So that obviously solves some of the problems of not being able to actually get to an X-ray. The X-rays are generally going to be found, these big ones, in some of the base hospitals, and then therefore you're lucky whether you go to a base hospital that has an X-ray. All right, so now we're thinking about the answer to number 3. What other types of sources might help you understand the problems? So just pause the video and make a little list in your notes about the kind of sources that we could use to find out more about the problems of the X-ray. And then when you're ready, unpause, we'll have a little check, and then we'll move on. All right, so hopefully you thought about things like diaries of soldiers who have had an X-ray. They're obviously going to be written in there how long it took, they were bored, whatever it was, or they were successful, they found the X-ray or the shrapnel. That could tell us something important. Maybe training manuals or journals from the doctors using it. They would write down in there the side effects sometimes, and they're bound to say people lost their hair. That's why we know these things, so that could be a source. We could also look at medical records, RAMC medical records from a base hospital on the Western Front, and they might have some notes in there saying about how long these things took as well. So obviously there's probably more sources we could use, but for the purposes of what we're here for, they're probably the main sources of things that you might be able to find out a little bit more. But the question you ask, remember, is nice and big and broad, and the source is really specific. So medical records from a base hospital on the Western Front, or diaries of a patient, a soldier who has had an X-ray, or perhaps the radiographers or the nurses who are doing the X-rays. They would write in there the things that they've seen, the problems that they've faced by doing it. That would be useful for hopefully a question that you could ask, something like, what were the problems of using an X-ray on the Western Front? That could be an obvious question, and then you answer that. All right, so hopefully you got at least those things, and if not, add them as we've just discussed it, and we'll move ourselves forward. All right. The answer to that question there, before we do move on, is that this allows us to see broken bones, bullets, and shrapnel inside the body. All right, that's the main purpose of the X-ray machine. So let's move on to blood transfusions, which is another absolutely epic breakthrough in the war. Consider the injuries that our soldiers are going to face. Blood loss is going to be absolutely critical to their death. and also any progress we can make in replacing some of that lost blood is going to save lives. So along with the x-ray and locating those bits of shrapnel, the broken bones and the bullets, that's going to save lives. Whereas before the x-ray, you might have missed some bits. This next bit, blood transfusions, is definitely going to save some lives. Okay, so on average, some information here. The body contains about 5 litres of blood. You may know this from your science lessons. And very quickly, the body will go into shock with too much blood loss and death. This is common during surgery, remember, in the medicine course, and definitely on the battlefields. Just if a bit of shrapnel hits the jugular or the arteries in the legs, then you're in a lot of trouble if you don't stop that blood loss. Remember, in the evacuation chain is going to play a big part in that. So if you're watching this for revision, you should definitely be confident on the evacuation chain by now. The 4 stages, but the RAP being the most important. Basic first aid and stop the blood loss. That is the priority before we move our soldiers along the evacuation chain. If you're watching this because you missed the lesson, we will shortly be doing the evacuation chain, but we did do it in our school in year 9. So hopefully you've got at least a little bit of a memory of that. So with the development of aseptic surgery and x-rays, it's now possible to carry out more complex surgery. We know that from the medicine course. Obviously, we're limited in what we can do in the trenches, but at the base hospitals, there's still now progress being made, certainly from the previous wars in the 19th century, but people are still dying despite these advances, and particularly due to blood loss. So this is what we're starting with. Can you just pause the video and write down basically what you see in these 2 photographs in how blood transfusions were done initially? And then unpause the video and we'll carry on. It's quite obvious, so say what you see. Don't try and be too clever about it. Literally say what you see. All right, welcome back. Hopefully you've noted things like it's from person to person. The person donating the blood is sat up while the soldier or the casualty is lying down. There's a lot of people watching in the first picture, probably because this is a new procedure, but that's a little bit strange, a little bit weird, really, isn't it? Watching the blood going from one person into the other. But these were the early blood transfusions. Remembering as well, the Royal Society, way back in 1660, in the Renaissance period, they began trying blood transfusions with animals to humans and things like that. So this idea isn't brand new, but the progress we're going to make is from the 2 photographs you can see there into mobile blood banks, which we can take out to the battlefield. And of course, today, when we think about blood banks and blood transfusions, no one really dies of blood loss anymore, unless, of course, they're far away from hospital and the bleed can't be stopped. Okay, so these are the early images of blood transfusions. Clearly problems there. It's going to take a long time, uncomfortable for both patient and the donor. So let's have a little think about now, and you need to write these things down. Okay, so problem. The blood coagulates really quickly. We know that if you've got a nosebleed or you've got a little cut on your arm or your leg or something, you know it stops bleeding quite quickly, and you get that sort of rubbery coagulated blood that then will become a scab as soon as it leaves the body. So the 2 photographs that we've just looked at, where there are going from the donor to the patient, it's probably highly likely the blood is going to start thickening very quickly and get stuck in the tubes, which then means the patient or the casualty is not going to be getting any of the blood. All right. So the attempted solution for this, and obviously today we're far more advanced than this, but these are the early things they tried. That their attempt to find a solution to it clotting is to add chemicals to it. So acids were put into the blood, but these could cause the patient other problems. So it wasn't an ideal solution, but they were just trying out these different chemicals to see if any of the chemicals kept the blood from clotting. If they could solve that problem, then that would obviously solve this first problem. And they do solve that, and we'll see that as we go through this lesson. But that's a really important breakthrough. A second problem is that the donor patient, his blood or their blood could be rejected by the casualty, all right, leading to death. So this was the first time that we've now discovered the idea of blood groups and different blood types. So in 1901-02, there was a sort of bit of work done on this. The discovery of 4 different blood types, A, B, O, and AB, AB negative, all these things, they're discovered. And it's probably important that you try and find out your blood group if you ever might need a transfusion somewhere at the roadside. Clearly, if you need it in the hospital, chances are they would know what you are. They'll do a blood test and they'll see. But that's probably quite a useful thing to know. So this would lead to less people dying from rejection and getting the wrong blood type put into your body. And again, this is a process of getting it wrong first and then ultimately finding a way to deal with that. And we've got the universal blood groups now, blood types. So anyway, whatever happened, if you were in a road traffic accident or something, they'd probably give you the universal blood group, blood type, so you'd be all right till you got to hospital. Then the danger of infection from the unsterilized equipment. Clearly, we're making all this progress, aren't we, with aseptic surgery at the end of the 19th century, but we're in the trenches, we're in fields, we're in outdoors, in farms and stuff. There's a problem. It's always going to be a little bit less clean and sanitary than it would be in a hospital back home. So the solution to this is trying to introduce aseptic surgery as much as possible. We know it solved the problem in hospitals back home, and very probably in the base hospitals on the Western Front, they're trying wherever possible to use aseptic surgery as well. So this is a little bit of a recap, a bit of a crossover into the medicine course as well, but just make the notes, but consider the most important bit here is the trying to stop the blood from clotting, coagulating, and this issue about the different blood types, okay? The bottom one, the infection, we know we're already dealing with that. We've got ideas that we'll wash our tools in carbolic acid or trying to make the area as aseptic as possible. This is more so for the base hospitals. Right, so problem, storage of blood. In 1915, so the second year of the war, it's discovered that by adding a chemical sodium citrate to blood, then it stops it from clotting. So this was the breakthrough that we've been looking for, isn't it? The need for donor-to-donor transfusions is now no longer needed to have that patient sat with the casualty receiving the blood, because the patient, the donor, can give blood somewhere else and it can hopefully be stored for a little bit because it's not going to clot. You will need to use it fairly quickly though. Then as the story develops, it's discovered that blood with sodium citrate in could be refrigerated for up to 2 days. That's really helpful, particularly if you're planning to do a massive attack. Like, I don't know, maybe the last few days of June 1916, you might think, right, we are going to have a lot of casualties, so let's try and get as much blood as we can to try and help some of these soldiers who are going to be injured. All right, then in 1916, all right, it was discovered that citrate glucose added to this blood could make the blood storage even longer. 4 weeks. That is a huge amount of time and massive progress in just a year. Hopefully you can see that. So now they can store blood for up to 4 weeks. That means they can start collecting blood much more earlier for a pending attack or invasion. This is good because we're going to have blood banks. The first idea of blood banks, this blood is going to be on standby, ready for these wounded soldiers as soon as they get to a hospital. And it gets even better as this lesson goes on because we develop mobile blood banks, which we can take to the battlefield. Okay, so you're going to need to know these facts about the blood storage. It's a feature of blood on the Western Front. The question one might well be something along the lines of, give one feature of blood storage on the Western Front or blood transfusions, and you just pick one of these things. Probably the sodium citrate or the citrate glucose. They're the obvious things because you get a bit of detail to add to guarantee the 2 marks. I would definitely do the citrate glucose. Allows you to store blood for up to 4 weeks, which is good for preparing for a battle. There's your 2 marks in the bag all day long. All right, so think about all this content and how it always will appear in the exam question. It's definitely a good thing to do. All right, so then 1917 is another important date. The first use of the blood banks at the Battle of Cambrai. So the Battle of Cambrai, you'll know by the end of this course, and if you're watching this as revision in year 11, hopefully remember the Battle of Cambrai is the first use of blood banks and the first large-scale use of tanks. All right, these things are important when we're thinking about the provenance of the source in question 2, the how useful are these sources question. When you're adding a bit of own knowledge, this is where you would say things like, this source was made, whatever the source is, in 1917 after the Battle of Cambrai, and I know that this was the first use of blood banks, which makes this source even more useful. You might say, this source is in 1916. This is even more useful because I know that this is when they discovered by putting citrate glucose into the blood, it could be stored for 4 weeks, meaning they could plan and take soldiers' bloods in the weeks before, preparing for a big attack. Those kind of things. Remember that own knowledge in the COP, content plus own knowledge. That is going to be really important. And remember, the provenance of every source will have a date on it, and it's those dates. You don't need to know the dates necessarily of when things happened, but you probably need to know the dates around when things happened, or the year that things happened in. So other things like obviously 1916, you're looking between July and November, you know that's probably going to be about the Battle of the Somme. 1915, the first use of gas masks. When you see that year, that should start triggering a little bit about what you are, why that's an even better source, because it's from the time of these discoveries, basically. Okay, so hopefully now we've got two really interesting bits of progress in our story today, the x-rays and the blood storage, but it's a little bit more about the blood storage now into the blood banks. But just pause the video and to just check you understand what we've talked about already. Put those red words into the gaps, and then when you're ready, unpause the video and we'll carry on. Okay, so let's check how we are on this. Sodium citrate stopped it from clotting. A citrate glucose solution allowed it to be stored for up to 4 weeks. This led to the creation of blood banks by the British. Scientists also discovered how to separate and store crucial blood cells, which could then be bottled, packed in ice, and used when needed after a battle, contributing to the growing blood banks. All right, so this is probably a nice little paragraph in a source question. If you have a question or a source about blood banks, this will be the own knowledge bit that you'll bring in based on whatever you've quoted from the source. All right, so hopefully you got all that right in that little summary checkpoint. So let's think about now a little bit more detail about this universal blood group. So we've established this type O as universal, which reduces the risk massively of a problem or a death or rejection from the wrong blood being transfused. The problem of clotting remained, and there was never enough blood to meet the demand, because certainly during 1916-17 with these massive battles, there's just too many patients, but we now can do this. So things will obviously improve as we go on in the war. Advances of storage of blood were made. We've established that. So now let's see what those things are. You need to know some of this information now, as always, for question 1, the features question, or for your own knowledge in the source question. Okay, so the main work on blood transfusions took place at a base hospital in Boulogne, all right, on the coast of France. We know this has been done using syringes and tubes from one patient to another. We're no longer doing that because we have the storage or the blood banks. So now we can put it in straight from the blood into the patient. Due to the success of these transfusions, more and more were being done at the CCS as a routine. Again, if you're watching this as revision for year 11, you'll remember, hopefully, that the CCS got so good at doing operations, which is the stage before the base hospital, the third stage of the evacuation chain, because they had all these bodies to deal with, and it essentially took a bit of pressure off the base hospitals. They started doing more and more things like blood transfusions at the CCS as routine, and that meant that when they got to the base hospital, hopefully the recovery and progress in their health was already at a slightly better place than waiting to get to the base hospital for a blood transfusion. All right, so we can see these pictures here of the early transfusion kits. This is from Geoffrey Keynes, a British doctor and lieutenant in the Royal Army Medical Corps, who designed this portable blood transfusion kit. This was able to take it onto the front line, or as close to the front line as possible, and into the CCSs, rather than obviously having more specific proper hospital transfusion kits in the hospital. This meant patients could get blood sooner. As simple as that, really. All right, so the main problem with Keynes' kit was the lack of refrigeration. So it did not really help store the blood. It just helped transfuse the blood. He did, however, add a device to the blood bottle to regulate the flow, which helped prevent it from clotting. So there's some technological advances there just to stop it from clotting as it reaches the tubes and gets outside. So we've got a problem here of how to store it, and that's going to be solved really quickly with ice. Okay, so now our sort of fact, really, again, for own knowledge, when you bring in the own knowledge part in a source that might be related to the Battle of Cambrai, it might be an inquiry into blood transfusions on the Western Front, and one of the sources is of a medic who saved a patient or something on the Western Front, on the battlefield, or at a CCS. Regardless, this is the kind of knowledge that you would need as your own knowledge to back up the quote that you pick or the content that you pick. So 1917, the Battle of Cambrai, the first use of stored blood. at the Battle of Cambrai. So before the battle, Oswald Hope Robertson stored 22 units of type O, universal, you know, that universal blood group that's not going to be rejected, in glass bottles, and they put them in ammunition boxes packed with ice and sawdust. So that kept the temperature relatively good, okay? During the battle, he treated 20 severely wounded Canadian soldiers with the blood, some of which was 26 days old. So we know that citrate glucose has kept it good. None of the wounded were expected to survive, so this was a win. You couldn't lose because they were going to die anyway, probably due to their injuries and going into shock. Of the 20 that they tried, this Oswald Hope Robertson, 11 patients survived. That is a huge success, major success, and has paved the way to the future successes of blood transfusions in battles all around the world. Okay, so our medics today will use probably similar techniques to get blood out to soldiers who are injured in modern warfare. Also, the modern blood banks around the country. Major hospitals have got blood banks, stand them by with blood groups ready to get to road traffic accidents or get around to other local hospitals, because storing blood is very easy now. Okay, so the gist of what we're saying here is this was the first time stored blood was used to treat shock, and although only on a small scale, we're looking at its potential here. It can be scaled up. So this is the progress of this lesson. Really brilliant. Okay, so the x-rays in themselves, although there are limitations, there are problems, just the point of them that we can now see where bones are broken, shrapnel and bullets and things like that, and of course the blood, we've able to store blood for longer, and we've improved the blood transfusions. Hopefully you can see this is really quite exciting and interesting, and it's because of the injuries that we're facing on the war, in the war, sorry. So that's this lesson done now. A fairly straightforward one, hopefully you agree. So just make sure you do understand these things in terms of the exam paper. So question 1, a features question, 1 feature of x-rays on the Western Front, or 1 feature of blood transfusions or blood storage on the Western Front. We've got plenty in here. We've got to be smart with our revision. We need to make sure that we're not wasting time trying to know every single thing about every single fact, because in reality we just need a little bit of our knowledge to back up whatever's in the source for the source usefulness question, and then obviously question 1, the 2 marker. We just need enough to say a feature of these 2 things. So as always, if you have any questions about this content, this lesson, let your teacher know. Otherwise, thank you very much as always, and we will see you on the next video. Thank you very much, and goodbye.